Okay, who among you has the middle number? Can you hear me?
Sir, is it 1?
Why did you say one? You're looking for the median here, middle number of this given data. Come on, it's easy to figure out. It's just for you to look for the center number. Which one is at the center? Chukwemeka, which number is at the center?
Sir, I know you can come again.
Okay, which number is at the center?
Six.
Are you sure? Look at it carefully. Ezekiel, which number is at the center?
Sorry,
That the
4.
middle number is 4.
Okay, that's correct. The middle number is 4. Easy way to figure that out. Cancel a certain number from the left. I can decide to cancel like 4. Cancel like 4. I still have 3. I can still cancel this while I cancel this. You can see that's what this is what is left standing. So those are the easy ways to do things like that. So the middle number here is what? Is 4. So 4 is the what? Middle number. Okay? So after getting the middle number, it's then easier to get what? Q1 and Q2. Okay. So from there, you can say the middle number here is 4. Okay. So after getting the middle number, that is exactly your Q2, which is the second quartile. To get the first quartile, you look at the entities on the left-hand side of the median. You get the middle of the left-hand side. You can give me the middle number on this left-hand side. What is it going to be? Tell me.
3.
That's correct. 3 is the middle here. That makes it our Q1. Then on the right-hand side, give me the middle number on the right-hand side.
7.
That's correct. So that's our Q3. So which means for this particular figure, Q1 is 3, Q2 is 4, Q3 is what? 7. Okay, I earlier discovered that the class wasn't recording. I don't know what happened. So I need to quickly give a quick review on some things so that you can have it captured. I've clicked the review button. The record button. I started with statistics here. Then we have different measures in statistics. We have measure of central tendency, of variation, and of partition. For measure of central tendency, it can be mean, median, or mode. Mean there are 3 types of mean. We have what they call the arithmetic mean, the geometric mean, and the what? Harmonic mean. That is arithmetic. So it can be what? Arithmetic, sorry. We can have what they call the geometric mean, and we have what they call the harmonic mean. When they use the word mean, ordinarily, they are implying the arithmetic mean, and that's the commonest form of mean. So we have the arithmetic mean is just finding average, which is total value over what? Total number of entities. Like in this case where you have 2, 4, 6, the mean is going to be the sum, which is 12, divided by the numbers, which is 3. That gives us 4. In order to get geometric mean is just defined as the nth root of the product of nth number. For instance, now, if a question wants you to find the geometric mean of 2, 4, and 3, okay, let's say a question wants you to find the geometric mean of a base. So, geometric mean, I'm only talking about this because sometimes they ask. Geometric mean means you have something like n square root of x1 times x2 times x3. It goes on that way. So in this case, where n is simply the number of entities you have there, we have 3 entities here, so the geometric mean is 3. That makes it cube root of 2 times what? 4 times what? 6. You get? So that gives us cube root of, so this I can write as 2 times, no, 4 times 6 is 24. 24 times what? 2 is 48. Square root, I mean cube root of 48. You know, you can leave it like that, or you can write this as 8 times 5. What is cube root of 8? You can tell me. Anybody? Cube root of 8. What is it? Oh, sorry, I made a mistake here. Either is 8 times 6. What's the cube root of 8? Anybody? Come on, you shouldn't be having problem with things like this. What number do you multiply 3 times with itself? That will give you 8. Hmm? What number do
2.
you multiply? Good. So the cube root of 8
2.
is 2. That's correct. So you're having 2 and cube root of what? Cube root of 6. Meaning, if they write the answer like this is still correct. So this is how you find geometric mean. It's just the nth root of the product of what? And numbers. So, but if the question wants to define what they call the harmonic mean, okay? Harmonic mean. The harmonic mean itself, harmonic mean, is just, imagine as you have a 2, 4, 6, somebody decides to reciprocate it by doing 1 over 2, 1 over 4, and 1 over 6. That's you reciprocating in this number. And you then choose to find the mean of 1 over 2, 1 over 4, 1 over 6. After getting that result, you decide to reciprocate the result again. That means you're finding harmonic mean. It's like you're trying to play with numbers. Like instead of finding the mean, you choose to find the mean of the reciprocals and you choose to reciprocate the result. So harmonic mean is simply defined as the reciprocal of the mean of reciprocals. So this is like saying 1 over 2 plus 1 over 4 plus 1 over 6 divided by 3. Then you choose to now reciprocate the result. This means by saying all raised to the power of minus 1. You get that? So these are as good as saying 3 over 1 over 2 plus 1 over 4 plus 1 over 6. A smart approach is to multiply up and down by 12. 3 times what? 12 divided by 12 times 1 over 2 is 6. 12 times 1 over 4 is 3. 12 times 1 over 6 is 2. So that gives us on top we have 36. At the bottom we have 11. Is it? Yep. So that gives us 36 over 11. So that's what we have there. And generally speaking, arithmetic mean is usually greater than geometric mean, and geometric mean is usually greater than harmonic mean. You can figure that out. In our arithmetic mean, we got the value as 4. In our geometric mean, we got the value as what? Cube root of 48. You can decide to press that in the calculator. You realize that it will be less than 4. Then in harmonic mean, we got 36 over 11. That's like 3 point something. That's generally less than, it's less than 3 point what? Point 3 or so. Yep. It's 3 point something, which is going to be less than the value of geometric mean that you got. So harmonic mean is usually bigger than geometric mean, while geometric mean of the same data is usually bigger than harmonic mean. I mean, let me rephrase that again. I think I made an error. Arithmetic mean is usually greater than geometric mean. Geometric mean is usually greater than harmonic mean for the same kind of what data. Then here I gave an example where we calculated the mean, the median, and the mode. The mean is sum of these numbers divided by 12. And why is it 12? Because when you count everything 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That gives you 12. 33 is the sum of everything here. That's this 3 plus this 6, that's 9. 9 plus 6, that's 15. 15 plus 8, that gives you what? 23. 23 plus 5 plus 5, that gives you what? 30 what? 33. 33 divided by 12, same thing as 11 divided by 4. Median means you're trying to get the middle data. Middle data in this case, easy way is, you must first have arranged it orderly. If you do some cancellation to the left, like cancel, 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 you just cancelled 5. Is it? Yeah. And also cancel another 5. 1, 2, 3, 4, 5. That leaves us two numbers in the middle. So that means the median is the average of 2 and 3, which is 2.5. Mode, which is the most occurring data, one appears thrice. Two also appears thrice. So that gives us two different possibility of mode. So the mode are 1 and 2. Any data that has two mode is called bimodal data. If it has a single mode, you call it unimodal. If it has a three mode, you can call it trimodal data, and so on. So we solve a problem like this by trying to guess what the mean of by trying to get the mean. Sorry, was it the mean? The number of male in this class. We've actually solved this already in the last class. Okay. Then we solve a problem like this also. I said easy way to solve this problem is not by trying to solve it mathematically using this equation. If you do that, it's going to stress you a bit because you have to do some kind of expansion. It's not like the expansion is difficult. Let me expand it so that you actually see it. Okay. What do you do? Hold on. So if I try to solve this by expansion, this is what we would have had. Would have had this n square. Expanding this alone would have given us n square plus 2n plus 1. Expanding this alone would have given us n square plus what? 4n plus 4 equals to 2030. N squared appears 3 times. That would have given us 3n squared. 2n plus what? 4n That would have given us 6n.
Mm.
Then 1 plus 4, that would have given us 5, equals to 2030. Now, the truth is, trying to solve this, it's not difficult to solve actually. This is a quadratic equation. But like I said, the aim of a student in the exam or writing a multiple choice problem is usually to pick the correct option. So if you can pick the correct option just by eyeballing the problem, you go ahead and do that. Don't try and solve the questions like this. Nobody's marking your steps. So that's why I gave you that. The easiest way is to go by utilizing the option. Like in this case, if we assume that because the question wants you to find the second number, it's telling you that the sum of the squares of three consecutive numbers is 2030. We are looking for the second number. So if we are assuming that the first one is 28, I mean that the answer is 28, then if 28 is at the middle, okay, fine, we'll do 28 square plus 27 square to the left and 29 square to the right. You can use calculator, but even using calculator here is still not smart. You look at the numbers that handle 7 ends this. 7 square is 49. 49 ends in what? 9. The second one, 8 ends it. 28 square, I will just focus on 8 square. 8 square is 64. 4 ends it. 29 square, I will just focus on 9 square. 9 square is 81. One's end it. If you add all this up together, that is going to give you 14, a number ending in 4. And we are not looking for a number ending in 4. We are looking for a number ending in 0. So it doesn't fit into that. If you look at 27, if 27 is at the middle, it means to the left and right, we have 26 and 28 square. A 6 square is 36, ending in 6. A 7 square is 49, ending in 9. An 8 square is 64, ending in 4. Adding this together will give you 19. It's not ending in 0, so it cannot be the answer. 26. If the center number is 26 square, then to the left, we have 25 square and 27 square. 5 square, 25, ending in 5. 6 square, 36, ending in 6. 7 square, 49, ending in 9. If you add this up, you're going to have 11 plus 9, which is 20, ending in 0. That is the answer. That's the answer because we need something ending in 0. If, for instance, okay, let's look at 25 so that you can see. If 25 square is at the middle, I would have been having 24 square and 26 square to the right. 4 square is 16 ending in 6. 5 square, 25 ending in 5. 6 square, 36 ending in 6. Now, if you do a 6 plus 5 plus 6, it's going to be what? A 17 ending in 7. It couldn't have been the answer. So these are easy ways to figure some things out as a candidate in the exam hall. Then I talked about finding mean. Mean is summation fx over what summation f. Like in this case, you just create a 3-column table and you have fx. Divide your fx is 1 times 3, 3, 2 times 3, 6, 3 times 2, 6, 4 times 2, 8. You add a hub, that gives you 23. Divided by the sum of f, that gives you 10. So from there we have the result to be what? 23 over 10, which is 2.3. A question asking you to find median here, you can just do summation f, which is 10, representing n. Median is usually n plus 1 over 2th number. If you do 10 plus 1, 11, 5.5. So this means it's standing between, because 5.5 lies between 5 and 6, this is standing between 5th and 6th number. So if you try and figure that from the table, 3 plus 3 is already 6. 5.5 is definitely within this part. So the number corresponding to that is 2. And I said alternative way is to write it out. Like in this case, 1 appears 3 times, write it out. 2 appears 3 times, write it out. 3 appears 2 times, write it out. 4 appears what? 2 times, write it out. So in this case, the median is going to be between 2 and 2, and that's 2. I talked about dispersion. I mean, measure of variation. It can be highest minus lowest, or you say maximum minus minimum. Mean absolute deviation is the mean of deviations from the mean. Deviation from the mean, which is D, means x minus x bar. That's deviation from the mean. How far a number is from the mean. You simply get it like this if there is no frequency involved. You get it this way if there is frequency involved. Similarly, variance is the mean of deviations from the mean. I'm sorry, I repeat, the mean of the square of deviation from the mean. You get the square of the deviation, and you get the mean of those square of deviation. If frequency is involved, you multiply by half. Standard deviation means square root of variance. Coefficient of variation means standard deviation over mean times 100. I give an example here where we calculated the mean, the range. The range is maximum minus minimum, which is 4 minus 1, and that gives us 3. Question wants you to find MAD, range, variance, standard deviation, and coefficient of variance. We calculated the mean, what was it called? Mean absolute deviation of 1, 2, 3, and 4. So first have your x column. We calculated the mean here, which is 2.5. That's our summation x over 4. Then we got the deviation from the mean. Deviation from the mean means x minus x bar, but we need the absolute value. Absolute value means we are not going to record negative. Normally, if we do 1 minus mean, which is 2.5, that should have been minus 1.5. But we are not interested in negative. That's why we quoted everything here as positive. When you sum that by what? When you sum that, that gives you 4. So that means our MAD is equals to 4 over 4. And that gave us 1. That's 4 divided by the fact that we have 14. 1, 2, 3, 4. Then we calculate the standard deviation too by getting the square of the deviation from the mean. 1.5 square this, 0.5 square this, see the bottom. You sum that together, we got 3. That means the variance here is going to be 5 divided by what? 4. So our variance there is equals to that. Standard deviation means square root of variance. So that's going to be square root of 5 over 4. Question of variance means you are what? You are dividing standard deviation. You are dividing standard deviation by the mean times 100. So in this case, standard deviation is square root of 5 over 4. The mean itself is given as 2.5, is it? Yeah, we got the mean as 2.5. Then times what? 100. These are you find coefficients of variation. So I give you a task here for you to find the median, which you got as 4, which we did by first arranging them and finding the middle number. Then I talked about quartiles, partitions generally. Measure of partition can be quartiles, deciles, percentiles, and fractiles. To get quartiles, you divide information into 4 equal places. To get deciles, you divide them into 10 equal places. To get percentile, you divide it into what? 100 equal places. I gave an example with quartiles. I said if you are given a particular set of data like this, and the question wants you to what? To divide it into 4 equal parts. In order to do that, in order to divide this into 4 equal parts, what you need are what? 3 distinct lines, like 1, 2, and 3. So if you do this division, you're going to get what? 4 different what? Data. 4 different points of division. Q1 is called first quartile or lower quartile. Q2 is called second quartile or middle quartile, which is also median. Q3 is called third quartile, which is what? Also called upper quartile. For you to find Q1, your first step is to arrange orderly. Like in this question now, they're asking to find Q1, Q2, Q3, rearrange, orderly. After doing that arrangement, you make an attempt to find the center number. So in this case, the center number is 4. How do we know that? You can easily cancel a certain number of entities. Like if I cancel 5 to the left, I cancel what? 5 to the right, I'll be left with 4. So that means the middle number here is going to be my median, and that's my Q2. For you to find the first quartile is going to be the middle number of the numbers that lie to the left of the center. So since this is the number that lies to the left of the center number here is 3. Similarly, for the ones that lie to the right of the middle, the center of such is 7. So that means for this problem that we just solved, my first quartile is 3. Let me duplicate that. So for this particular problem that we just solved now, first quartile is 3. The second quartile is 4. And the third quartile is what? 7. Okay. Now, what if I have almost the same set of data? Let me use the same set of data. I just wanted to see something. Control C. Okay. So imagine we have the same set of data, but instead of having this 10 here, let's say it's not there. Now we have the number reduced to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the question wants you to find Q1, Q2, Q3. This is already arranged. Who can give me the center? The center number here, do you agree that in this case, it's not going to be a whole number? It's going to fall between 2 numbers. Who can tell me the numbers it will fall in between? Anybody? The center number will be between what and what here? Figure it out. Look at it carefully.
4 and 6.
Did you say 4 and 6?
No, 3 and 4.
3 and 4. That's correct. So the center number is going to be between 3 and 4. And that's because, hold on. Okay. So that's because if we try to do some cancellation from the left, let's cancel 4 here. Let's cancel 4 here. So you realize that I'll be left with what? 3 and 4 at the middle. So, which means in this case, the median is going to be right in between 3 and 4. Let's call that Q2. So, who can give me the middle number of what we have to the right here? To the left. What's the middle number of what we have to the left here?
3.
That's correct. So that will make this our Q1. Hold on. So that will make this our Q1. Then somebody should give me the middle number of what we have to the right here.
7.
That's correct. So this would be our Q3. So we have Q1 and Q3. So in this figure here, we have Q1 to be 3, Q2 to be 3 plus 4 over 2, making it 3.5, and Q3 to be equals to what? 7. Okay. So now let's say we have almost the same set of data, but here I then reduce it further and I have this. Can somebody give me the middle data here? What's the middle? What's the middle of this data?
3.
That's correct. So the middle of this data is 3, and that is it here. So this is Q2. Now, who can give me the middle of what we have to the left? What will be the middle of what we have to the left? It's easy to figure out. It's not going to be a fixed number. I mean, it's not going to be an integer here because you can see that it's visibly lie between 2 and 3. So that makes it 2.5. Do you agree that it's going to fall somewhere here? Do you agree? Do you all agree?
Yes, sir.
Okay, so that's your Q1. And if you check the one to the right too, it's going to fall somewhere around here. So that's our
That
what? Q what? Q3. Good. So Q1 is 2.5. That's something you get by adding 2 and 3 divided by 2. That's 2.5. Then Q2 is directly 3. Q3 is going to be 6 plus what? 7 divided by 2. That gives you what? 6.5. Okay. Let's take one more example, then we can call it a day for today. So imagine you have, let's say we have 4, 3, 1, 4, 10, 11, 7, 8, 9, 8, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's say we have 6. Okay. So let's arrange this orderly first. The orderly arrangement, here I want you to find Q1. I want to find Q1, Q2, and what Q3. The other arrangement of this, let's start with the smallest here. We have 1, which appears once. There is no 2. There is a 3, which appears once. There is a 4, which appears twice. There is no 5. There is a 6, which appears once. 7, which appears twice. 8, which appears twice. 9, which appears once, 10, which appears once, 11, which appears once. So you have to count to be sure that you have the right figure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have the right figure. Okay. Now tell me where the what? Where Q2, we want to find the middle data. Where will Q2 lie? Just tell me where to lie.
Between 7
7
and
and
7.
that's correct. So Q2 is going to lie between what? 7 and 7. So we're going to have it somewhere around what? Around here as our Q2. So then we now have this to the left. Tell me where will what? Q1 lie? Q1 will lie there. Okay, I'm listening. Q1 will lie here. It should be the middle of this thing here. It's lie where? I'm listening. It's easy to figure out, so it's not something you think too much. What's the middle? The middle of this is gonna lie between what and what? Do I still have you? Are you there? Okay. So I will assume that you can no longer hear me. So in order to round up this class, let's just go straight. This is going to be Q1. And to the what? To the left, to the right of the data is going to what lie between what 8 and 9. So that's going to be what Q3. So from there, our Q1 is going to be 7 plus 7 over 2. That's going to be 7. Q2, I made an error there. That's Q2. Let's start with Q1. Q1 is going to be equals to 4 plus 4 divided by 2. That's 4. Q2 is going to be 7 plus 7 divided by 2, and that's 7. Q3 is going to be what? 8 plus 9 divided by what? 2, and that's going to be what? 8.5. So Q1 equals to 4, Q2 equals to 7, Q3 equals to what? 8.5. All right, for today's class, I'm going to what? Stop here. For assignments, take this as an assignment. I have 7, 8, 10, 8, 3, 4, 2, 5, 6, 7, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Find Q1, Q2, and what? Q3. That's first part of the question. Then second part of the question, find the figure 1, mean. Figure 2, range. Range of the figure. Okay. On this note, we'll call it a beautiful day. See you in the next class. And bye for now. Take care.